Welcome back. Today we are going to delve deep into three-dimensional objects or 3D objects. So we're going to use the skills that we learned in the last video, which is SOHCAHTOA, to help us solve 3D problems. Now I've got two dot points here, which is the first one, using Pythagoras theorem to solve 3D problems. The reason why we're using Pythagoras theorem is because it deals with right angle triangles. So it'll be helpful for us for solving 3D problems, as well as I said before, which I haven't written down here, we're going to also be using SOHCAHTOA. Okay, so that's my first dot point. My second dot point, which I would like to highlight that this is very, very important and a really good habit to do, is to draw any identified right angle triangle, any of them, separate from the main diagram. The reason being is because there'll be some questions where they'll give you the main diagram, and there'll be some questions where you won't. Therefore, you need to draw your own diagram. And in both of those two types of questions, you need to make sure that you draw the right angle triangles that you see, because it'll help you to solve and be more methodical in your working out. Okay, so those two dot points. Let's get into our example. So my first example right here is this rectangular prism has side lengths 2, 3, and 5 centimeter as shown in the diagram. Calculate the length of AC and hence the length of AF in surd form. Okay, so first off, before even solving these questions, I need you to get into the habit of breaking down those questions, particularly worded problems. So I'm going to highlight or underline really important points, which is a rectangular prism, as well as its side lengths of 2, 3, and 5 centimeters. The reason being is, like I said, there'll be types of questions where they won't give you a diagram, and therefore highlighting these particular important points, it'll help you to identify what type of object it is, what are the side lengths, and so on. Okay, another thing is I need to highlight what am I actually answering? What question am I actually answering? The question says calculate the length of AC, as well as, well, let's just do it in a different color, the length of AF, with the condition of it must be in surd form. If we don't know what surd form is, super easy. Think about it as anytime that you see a squared root, that's a surd form. Okay, squared root, cube root, whatever. Okay, that's surd form. All right, we've broken it down, and luckily they've given us a diagram. Okay, now I need to break down what I have. Question says length of AC and finding also the length of AF. Okay, where is my AC first? Let's just identify that. My length of AC is right here, right? And then my length of AF is from this point to the other side, to the other point here. Okay. Let's speculate. I suspect that this will be a right angle triangle if I connect the F and the C point here together. Okay, yes, it does look like a right angle triangle. Right, I'm going to now use my second dot point, which is drawing any right angle triangles that I see on the side, separate from the actual main diagram. It's a right angle triangle. I'm going to label it as FCA. Okay, there are some things that I know. I know what FC is, which is 3 centimeters, right? Just like the ones here. The exact same. 3 centimeters. But, okay, I don't know what AF and AC is, right? Okay, maybe, let's see. If I were to look at this diagram here, I know what AB is, and I know what DA is, right? AC is somewhat, if I were to draw it like this, right? If I were to draw the actual rectangle, the bottom rectangle of this rectangular prism, just like this. So this will be AC, right? C, B, A, D. Okay, I know what AD is, which is 2 centimeters. The other side should also be 2 centimeters. AB will be 5 centimeters. Looking here in this red here, I know 2 information to help me solve AC. Okay. So first off, I'm going to solve for AC before solving for AF. So first is find the length of AC. Okay. All right. Looking at this diagram here that I've drawn, right, I can tell that I need to use Pythagoras theorem. So let's write our formula down. C squared equals A squared plus B squared. My AC length will be my Pythagoras, my hypotenuse. So I'm just going to substitute AC squared equals to A, which is 2 squared, plus B, which is, I'm going to substitute 5 into that, so 5 squared. Put this into your calculator, and you should get 29 equals to AC squared, right? Now, how do I get rid of a squared? Is using a square root. These two will cancel out. And what I'm left with is AC equals to square root of 29 centimeters. All right, it's in third form, right? I'm abiding by the condition. That's good. Okay, I've now figured out what AC is. I'm going to write it down into my main diagram right here. Square root of 29 centimeters. Okay, looking at this diagram, I can see that I can also use Pythagoras theorem. Okay, so I'm going to draw it here. Find the length of AF. I'm going to now draw it right on the side here. So this is FCA. I know that this is the square root of 29. This is 3 centimeters. Let's use Pythagoras. All right, same thing. Oh, writing the formula. C squared equals A squared plus B squared equal to, substituting my C, which is AF squared, just like so, equal to 3 squared plus square root of 29 squared. Okay. I'm going to put that into the calculator. So 3 squared will be 9 plus, I've got a square root and a squared on top, right? Therefore, these two will cancel out because they're the opposite. And what I'm left with is 29. I put that into the calculator and I should get 38 equals to AF squared. I'm going to just write it down here. AF will equal to the square root of 38 centimeters. Right? The opposite of a squared is a square root. And that's what it is. I solved for the length of AC as well as the length of AF. That's for question number 1. Question number 2. The rectangular prism has dimensions 5, 8, and 11 centimeters as shown in the diagram. All right, again, get into the habit of it. Highlight, it's a rectangular prism. The dimensions are 8, 5, and 11. That's my diagram. All right. My first question is calculate the length of OM. So I'm going to highlight this. This is what I'm trying to calculate, the length of OM. All right, let's look at our main diagram. OM is right here, right? And if I use what I learned in the first question, I know what OL is, and I know what LM is. And if I look at it, it kind of looks like a right angle triangle. Okay, so I've drawn a separate right angle triangle right down here. in the green. And now I'm going to just label it. OL should have the dimension of 8 centimeters. LM should have the dimensions of 11 centimeters. And what I need to find is OM. I'm just going to write down as X. Okay, now let's try to solve using Pythagoras. Okay, C squared equals A squared plus B squared. Substitute C squared for X squared equal to 8 squared. That's what I substituted. And B will be 11. So I'll substitute that as 11 squared. Put this into your calculator and you should get 185 equals to X squared. How do I get rid of a squared? It's using a square root. These will cancel out. And X will equal to square root of 185 centimeters. Okay, that is all for question A. Now let's look at question B. Question B says, calculate theta. This is theta here. Okay, theta. Calculate theta, the angle between the line PM and the plane LMNO. All right, let's look at our main diagram. Our LMNO is this plane right here. So if I get rid of these here, this is my plane. And what I need to find is, I need to find the angle between PM. PM is right here. So that's PM. And the plane. Okay. Therefore, it's this one right here. The plane. Okay, that's what it means as in the line between PM and the plane. So I need to find the angle. If I were to draw like that, connecting P and O, that means that this is a right angle triangle, right? The angle will be this one right here. Reason being is because it's between LM and O, as well as connecting it to the line of PM. Okay, I'm going to draw and isolate that triangle, and which I've got here. All right, I know what OM is from my previous question, which was the square root of 185 centimeters. Okay, looking at this one right here. Then what do I know? What's PO? Let's look. PO should equal to 5 centimeters. Okay, this one right here. So this should be 5 centimeters. And what I need to find is the angle. Okay, let's use SOHCAHTOA. So I'm going to write SOHCAHTOA here. SOHCAHTOA. Let's use, so the opposite of my degree, I'll call this the opposite, denoted as O. The opposite of my right angle triangle, I'll call that the hypotenuse. And the last side, I'll call it the adjacent. Okay, which I guess, information do I have? I've got an information on my opposite side and my adjacent side. Therefore, I need to use O and A. I need to use TOA. Okay, so I've highlighted that, I've circled it, and now I'm going to use it. Okay, tan theta equals to, using my SOHCAHTOA, O over A. My opposite is 5, looking at the diagram, over A, which is the square root of 185. All right, again, how do I find my angle? I'm going to go theta equals to, the opposite of tan is tan dash 1. Open the bracket and put in 5 over square root of 185. Put this into your calculator, right? And you should get 20 degrees in 11 seconds, making sure to put or press DMS or the bubbles button. Okay. And that is it for question number 2. See you in the next one. Bye.